This is what the future of life off the Earth looks like. The Moon is a fully developed commercial hub and way station for traveling deeper into space. Anyone who wants a truly out-of-this-world vacation destination can now look to the stars and back down at Earth. The first permanent settlers of Mars arrived to self-building habitats that produce air, water, and food. With a new generation destined to be born on alien planets, this is the next step in our evolution as a species.
Well, this is the coolest thing I've done in a long, long time.
Today, scientists are blazing a trail to this very future.
This is just a remarkable structure from an engineering perspective.
I want to know what breakthroughs are being made.
Water could be used as rocket fuel, so we could use the moon as a refueling station.
That is a big, hairy, audacious goal.
That will forge a future to
Here we go.
life off Earth. My name is Justin Schaefer, and I'm an environmental scientist. Since I was a kid growing up on the south side of Chicago, I've always dreamed of exploring space. When it comes to the very expensive prospect of sending humans to live in space, many people ask, why should we go? But as someone that's concerned about climate change and the health of planet Earth, should we be thinking about moving to another home? If so, how will we actually build an outpost on an alien planet and then survive the lethal environment of outer space? I'm in Columbus, Ohio to meet someone who knows firsthand. Former NASA astronaut Dr. Catherine Sullivan.
Kathy was a truly inspirational figure to meet. I was an intern at NOAA, the National Oceanic and Atmospheric Administration, the first time we met. It was then that I saw the possibility of being an astronaut as something that was very real.
Incredibly, this prospect seems possible in my lifetime. To find out just how and when humanity will accomplish this, I'm catching up with Catherine, my old mentor.
I just remember listening to you speak. It made me want to be an astronaut. It made me think that it was actually a feasible thing.
Well, thanks. That makes me feel really good. Welcome to our planetarium.
Whoa.
You can project things on this dome that will take you anywhere in the universe.
Catherine is a geologist, deep-sea explorer, and was the first American woman to walk in space. She knows a thing or two about life off Earth.
You spent a lot of time in space, right?
My total is like 23 days.
Catherine flew multiple shuttle missions during her 15 years at NASA.
Once you're in orbit, you have effectively no weight. To be able to sort of drift in the air like particle of dust is pretty magical.
But space is dangerous. A vacuum devoid of atmosphere, water, and oxygen. Everything we need to survive.
You think the human body as is designed to tolerate space for years, decades?
There are definitely some unknowns and some ifs about that. If our bodies are not sensing a gravity field, the calcium in our bones, which gives our bones their strength, that starts to leach out.
Not only that, absent protective gear, long-term exposure to radiation damages DNA and can lead to cancer.
You can certainly lose your life in space, and you've got to be aware of that and clear-minded about the risks of it.
Much of what we know about these dangers comes from studying the long-term inhabitants of space stations orbiting Earth. NASA astronaut Scott Kelly spent nearly a year on the International Space Station, or ISS. As a result of this mission, Scott experienced cognitive decline, damage to his eyes, and even changes in his DNA. Before we can attempt to build permanent bases on the Moon or Mars, we're going to have to figure out how to protect our bodies and minds from threats like these.
It's one small step for man, one triumph leap for mankind.
But where there's a will, there's a way.
Mars now is, I think, like the moon was in the 1960s, a big, hairy, audacious goal. I definitely think exploring Mars and figuring out what would it take to get there, I'd love to see us do that. I think it's really wired into human nature to be exploring, to not explore our place in the cosmos, to not continue to expand our understanding at the largest scale of where we live and our place in the universe. I think it's just short-sighted.
3, 2, 1, 0. Liftoff. We have a liftoff.
With so many unknowns surrounding the welfare of humans in deep space, NASA is first setting its sights on a return trip to the moon. The Artemis mission, scheduled to launch by 2024, is the first step towards establishing a permanent human presence at the moon, with the ultimate goal of using it as a springboard to the Red Planet. A spacecraft orbiting the moon will serve as a hub for research on the lunar surface. The goal is to learn how to live and operate on another celestial body while proving technologies necessary for a mission to Mars. But at present, lifting people and materials above Earth's atmosphere is extremely expensive. To build a moon base, we'll need to find cheaper methods and reusable equipment. I'm in Colorado to visit Sierra Nevada Corporation, who is working with NASA on this heavy-duty problem.
Welcome to Sierra Nevada Corporation, home of Dream Chaser.
Wow, it's beautiful.
John Curry is the director of the Dream Chaser project.
Dream Chaser is a space plane, so it's just like riding on an airplane, landing horizontally on the runway. As you know, the space shuttle flew 135 missions and worked very well. What makes Dream Chaser different is that it's so much cheaper. The space shuttle was just too expensive to maintain. We're lighter weight, we're stronger than shuttle.
The Dream Chaser's clever design and carbon fiber body allows it to hold enough cargo to supply astronauts on the ISS for half a year. With innovations like these, it can be flown 15 times before maintenance, keeping costs down. The space shuttle required maintenance after each launch. With the retirement of the space shuttle in 2011, the Dream Chaser is now the only spacecraft capable of delivering people, supplies, and science experiments to the ISS, and then navigating back to Earth for a gentle runway landing. It can also perform the whole mission autonomously, without a pilot.
I believe this vehicle is going to be critical to transporting humans to and from space on a routine basis.
Sierra Nevada plans to conduct 6 ISS resupply missions by 2024. And unlike the shuttle, which launched aside 2 boosters and a fuel tank, the Dream Chaser is designed to be launched into orbit, wings folded, atop a rocket.
So what's the top speed something like this would reach?
Orbital velocity is 17,500 miles an hour.
Dream Chaser will circle the Earth 16 times a day at this speed. But when it returns and enters the atmosphere, it practically has to grind to a halt.
What's cool about this and very innovative about this design is this is called a lifting body, meaning the lift that you get from this vehicle is actually the body itself rather than the wings.
Unlike most planes, Dream Chaser's actual body, not its wings, takes the full force of the air pressure. The underside of the Dream Chaser is wide and flat and pushes against the atmosphere to slow re-entry.
Probably the biggest risk for Dream Chaser is the entry, because you see 3,000 degrees Fahrenheit coming back through the atmosphere to get to the ground. So you got to make sure that this vehicle can survive 3,000 degrees Fahrenheit.
The Dream Chaser can land anywhere there is a 10,000-foot-long runway, which means it can return to any major airport in the world. For the Artemis moon mission, NASA is looking at a radical technology to house the astronauts: inflatable habitats. These habitats will connect to a core power module dubbed Gateway. Sierra Nevada designed a system called the Large Inflatable Fabric Environment, or LIFE, that can dock to the Gateway module.
We have a module you could actually turn into a space station, and that would be what you would want to take to the moon.
The habitat can be folded in a compact manner for launch and then later expanded in space. Once connected to NASA's Gateway module, inflatable habitats will serve as a base for researchers traveling to and from the moon.
The key elements to get us to the moon is we have to put the infrastructure in place to make sure that people can actually stay there Once you've got that, then you have a permanent presence in space.
Technologies like these are forging the path for humans to build a permanent home off Earth.
In the future, inflatable lunar habitats prove safe and reliable gateways to the moon's surface. On a weekly basis, researchers shuttle between the moon and Earth on advanced space planes. With enhanced rocket boosts, travel time is reduced over the 400,000-kilometer journey from 4 days to just 1. With the completion of a permanent research base on the surface of the moon, space agencies approve both the base and the orbiting station for commercial uses. Space tourists can even enjoy a one-week stay.
With inflatable habitat technology, a permanent presence on the moon might become a reality sooner than we think. But with virtually no atmosphere, further exploration of the lunar surface will require new technologies to protect explorers from the sun's lethal radiation. The last spacesuits designed to function on the moon were custom fabricated for the Apollo astronauts more than 50 years ago. These suits were both expensive and cumbersome. I'm in Brooklyn, New York to meet Ted Southern, the co-founder of Final Frontier Design. His company is developing the next generation of spacesuits designed to overcome these limitations.
Whoa, this is pretty cool.
This is where we make spacesuits. Generally doing prototyping of suits. We work with NASA and the commercial space industry to make suits work better. This is an EVA suit, extravehicular activity. So this is when you leave the vehicle. It's like a spaceship for one person.
In the days of Apollo, spacesuits were only worn for a single mission. Final Frontier is designing reusable suits that are flexible, lightweight, and durable.
Now NASA's talking about going back to the moon, but for a lot longer period of time. So they want suits that are more mobile, that won't wear you out, and that can last longer. There's no reason for a human to go to the moon or Mars unless they can get outside and walk around.
The key to surviving extreme environments like this lies in the pressurized EVA suit.
It's like wearing a basketball, which is where the challenge of like, how do you get a basketball to fit a human being and how do you get it to move like a human being?
Pressurization is essential to surviving in the vacuum of space. Without it, blood would fill with bubbles and the body would puff up to twice its size, causing death in less than 2 minutes. But pressurizing the suit to protect the wearer from the harshness of space creates a problem with agility.
So you lose a lot of dexterity.
Dexterity, tactility, range of motion, all these things are really important. We actually have a tool that allows us to test the gloves without having to put on the whole suit.
Oh, really?
Can you
Nice.
check that out?
Yeah.
Final Frontier won a prize from NASA for their superior pressurized glove design.
This is a pressure chamber, and there's a pump underneath that will pull gas out from the chamber. Stick your hands in through the ports.
The chamber is designed to create the same extreme vacuum of being in space.
You're at about 4 psi lower than ambient. You're approaching NASA's EVA spacesuit pressure.
Okay, so this is the problem that astronauts have.
Exactly.
Almost feels like I have a robot hand. Yeah.
I'd really appreciate it if you solved that Rubik's Cube, too.
Let's see. Do you think that there's anything wrong how these things should be designed for people?
Yes. Spacesuits are traditionally built like big bubbles. Theoretically, there are garments that could tighten around your body equivalent to the gas that you're breathing, which would be much tighter fitting, potentially more mobility, that could revolutionize how spacesuits work. We're going to let air back into the chamber.
Oh, wow. That definitely changed very quickly.
But that's not the only problem they're solving. Moon dust is sharp and very fine-grained. The particles get everywhere and can cause life-threatening injury if inhaled. Final Frontier's EVA suit has a unique feature to prevent this from happening. The rear port can dock directly with a landing craft or rover.
Is this like an entrance on the backside? Is that?
That's right, yeah, you get in through the back. This will allow an interface with a suit port so you can be inside your rover and jump in the spacesuit without bringing dust into the rover. It's also easier on the astronauts to get in and out this way. NASA's current suits, you get in through the waist, and that means you have to really contort your shoulders.
It's like a dance move, kind of.
Yeah. And there are a lot of astronaut injuries from suits, but one of the most major ones is shoulder injuries.
From getting into
the suit.
Ted's got a surprise for me. He's letting me try on the pressure suit, which is something that usually only astronauts get to experience.
Right now, we have air flowing in through the umbilicals here on your chest. The only place it will come out of is right here at your regulator. You can kind of push your head back.
With my pressure balanced, it's time to experience what walking on the moon or Mars might be like.
Try walking around in that.
I feel like I have no joints right now.
Yeah.
I'm like a tin man. Well, this is the coolest thing I've done in a long, long time. I don't know if I ever did anything cooler than this.
With advances in new flexible protective suits like these,
Hey, welcome back.
the path to exploring other planets seems clear.
In the future, EVA suits for space exploration are as flexible and comfortable as wetsuits. Skin-tight elastic undergarments apply stable mechanical pressure against the skin, eliminating the need for air pressurization. These suits also compensate for lower gravitational pull, allowing scientists to explore just as easily as they can do on Earth.
Even with protection from the harshness of space, astronauts won't survive a week on an alien planet without one living essential: water. But the cost of bringing enough liquid water from Earth to support even a small base on the moon or Mars is astronomical. This means, if we're going to establish outposts in space, scientists must find a reliable source of water elsewhere. I'm near LA to meet Dr. Dean Bergman at Honeybee Robotics. Honeybee Robotics is developing cutting-edge tools to help NASA find and extract water on the moon or Mars.
Nice.
Why don't we go look at some cool things?
All right.
We are developing these technologies to be able to create a sustainable civilization off of our planet. Water is the most precious resource in space just because we can use it for so much. And the more we can collect, the more ability we have to really live off-world and on other planets.
In 2009, NASA confirmed the presence of water on the moon in the form of ice. Some estimate more than 100 million tons might be found under the surface at the moon's south pole. Not only will future spacefaring pioneers need this water to drink and grow food, this essential liquid has another potential important use in space. By splitting water into hydrogen and oxygen, both of these molecules could be used as propellant for spacecrafts.
Water can also be used as rocket fuel, so we could use the moon as a refueling station on the way to Mars, potentially.
Honeybee's drills were sent to Mars on multiple missions to determine what was below the surface. In 2002, the Mars Odyssey orbiter detected large amounts of water ice beneath the surface. So in 2007, NASA launched the Phoenix Mars lander to search for it.
We were part of the Phoenix mission. The idea was to uncover the ice of the poles of Mars. So we would scratch a line on the surface and uncover the ice.
Wow, well, this is a powerful thing to be in the presence of.
Yeah.
And the Phoenix mission discovered what they were looking for: the first direct evidence of frozen water on Mars. In 2018, the European Space Agency's Mars Express orbiter discovered liquid water for the first time beneath the South Pole region. So Honeybee is developing a method to extract the liquid water with this, the Trident drill with Planetary Volatiles Extractor, or PVEX. And Vince Vendiola is showing me how it works.
So this is Honeybee's large vacuum chamber. It is a 1 meter by 1 meter by 3 meter tall thermal vacuum chamber. PVEX is a coring drill with integrated heaters and electronics to be able to capture water from lunar ice.
Very cool stuff.
The large vacuum chamber is used to recreate the same low-pressure atmospheric conditions found on Mars.
So let's do a drill test. Close the chamber here.
Here we go.
I'm going to lower the foot pad onto the surface.
This hollow core drill can dig into the lunar or Martian underground and collect water ice and icy soil meters beneath the surface.
What's that noise?
That percussion sound is our cam spring mechanism, which gives us an additional weight on bit.
It's kind of like a space jackhammer.
It's like a space jackhammer. And our software is designed to where we only percuss when the system detects that you're drilling into something hard, so that we save a lot of energy.
So it's taking a core sample right now?
Right, so we capture our sample course and then we activate heaters.
It's a process to extract liquid water on the Moon or Mars. First, the heaters must vaporize the ice. Then, the vapor will be collected within a cold trap and converted into solid ice for storage. Without this system, the liquid water would instantly evaporate and be lost.
Is there water in there now? Or?
Let's see what we got.
Okay.
Open up the chamber.
The epic reveal.
Hey,
oh, nice. Nice. This is the future right here.
The red planet has plenty of ice, some buried just inches below the surface. Using this technology to extract it will make a future life off Earth possible.
In the future, advanced robotic drilling technology sets off a gold rush in space. Entrepreneurs race to prospect asteroids and comets across the solar system. Autonomous probes mine these celestial bodies for precious metals and water ice. Once the ice is converted into rocket fuel, it is more valuable than gold. Trading posts and way stations emerge across the solar system to process this precious cargo and further the exploration of space.
With a large source of water ice identified on Mars, building a long-term base there sounds more and more viable. But what other problems will scientists need to solve before people can live in a hostile environment, on missions that could stretch for years?
Yeah, we are definitely on another planet right now.
I'm in a desolate part of Wayne County, Utah. Here, it certainly looks like Mars. I'm heading to the Mars Desert Research Center to meet Commander Mark Levesque and his team.
Hi, how's it going?
Welcome. Let's head on upstairs.
All right. Hey, folks.
Let's meet it.
Rich?
So we have a nice international crew here.
This habitat serves as an Earth analog of an early manned research base on Mars. It contains the essential components a future team would need for a long-term mission, including living quarters, greenhouse, science labs, and observatories.
There's a variety of research that goes on here: psychological, geological, astronomical.
The water-parched extremes of the Mars Desert Research Station, or MDRS, make it perfect for simulating a mission on Mars.
This is one of the closest analogs to Mars on Earth, given the landscape, given the isolation, given the sporadic communications.
At the MDRS, every effort is made to simulate the challenges of conducting research in a hostile alien environment.
Any outside activity, such as exploring the area or conducting projects out there, we have to be in spacesuits, and we have to go through a depressurization for 5 minutes in the airlock.
Science time.
Okay, we're going to take 2 rovers with us, and these 2 guys are going to go in the second rover.
Roger that.
Hello, Hab. This is Ares 1. That's us entering the airlock now. Over.
Leaving the airlock. Hab, airlock is secure.
A primary scientific objective of the first research mission on Mars will be searching for signs of life, past or present. People have been preoccupied with finding life on Mars for centuries. In the 19th century, while mapping the red planet with a telescope, Italian astronomer Giovanni Schiaparelli saw what he thought to be water channels. And many believed they were artificially constructed canals built by Martians. But with the arrival of the first Mariner missions to Mars in the 60s and 70s, scientists confirmed that there was not an advanced civilization. However, recent discoveries of geological formations have excited them about the possibility that some form of life could have once existed.
Right, so we're gonna get out now.
All right.
So we're heading for that boulder on the second peak.
The geology surrounding the MDRS is comparable to what the first researchers on Mars will encounter.
Just want to be on the lookout for any minerals or interesting rocks that we can evaluate.
To answer the question of whether primitive forms of life existed on Mars, future researchers will look to rocks. By peering inside these rocks, they may find the presence of biomolecules or even fossils of microbes.
We're at the top of Kissing Camel Ridge. We're going to mark the spot on our GPS.
How about I can give you the grid reference now? 4249540. Over.
Yeah, this is the spot for gypsum.
Gypsum is a mineral that exists on Mars as well. In 2011, the Mars rover Opportunity discovered veins of gypsum in the rock beds. Because gypsum forms in the presence of water on Earth, scientists believe that bodies of water once flowed on the red planet. The team here in Utah is simulating this search.
We're going to keep our eyes open. When it's covered in mud, no one knows what it is.
On Earth, gypsum has a practical use. It's used in the home, in walls and plaster. On Mars, it could also be used for building new habitats.
So you'll get a lot of gypsum on these clay beds. It's just pieces of rock that push up.
That gypsum there?
Yeah, here's some gypsum actually. We've got a little right here. Some is nice and clear and pretty, and some is really cloudy. So we'll just mark the location on GPS and then analyze them back at the lab. Sounds good.
By examining the gypsum and its surroundings on Mars, scientists might one day find evidence of life and prove it also evolved on the red planet. Back at the lab, the team processes and examines the stone.
Part of the interesting thing about being in the simulation is you start thinking through like, well, what would we need for this and what would we need for that? But on Mars, everything has to be either with you already or you have to like cut up cans to make it work.
Right. But I can imagine when we first visit Mars, we're gonna have to have scrappy operations like
Right.
this.
There's gonna be stuff that you're like, gonna have to make it work. And this is definitely a great practice for that.
While some team members are working out the technical challenges of life off Earth, others are studying the researchers themselves. PhD student Rich Whittle is studying how humans behave when confined for long periods of time in aerospace environments like these.
What we're looking at here in particular is the psychology of crews in isolated confined environments. We're looking at sleep quality, profile of moods, positive and negative affect.
Will being cooped up in isolation drive people crazy? Any mission to Mars would involve being away from Earth for years. A one-way trip alone takes about 8 months. And the first habitat likely wouldn't be much larger than the space capsule's tiny quarters.
So I guess this is one of the rooms, right? This is very humble.
And then this is probably the deluxe suite.
The commander suite. Oh, you can see light. This is luxury, man.
I know. I'm feeling guilty.
Mark has experienced the psychological impact of living in isolation firsthand.
I mean, Mark was done a winter over in Antarctica.
Yeah?
At South Pole, yeah.
So it's 3 months? Or?
Oh, no, a year.
Oh, wow.
It's a challenge. You're locked in with people. You can't leave. That kind of confinement sort of forces people apart.
Towards the end, personality conflicts started to come out.
One of the longest Mars mission simulations took place in Russia. Called Mars 500, 6 volunteers were isolated for 520 days. They even simulated the up to 20-minute radio communication lag between Earth and Mars. The experiment showed that prolonged confinement led to sleep disorders, fatigue, and depression. Before the first crew can be sent to Mars for the long haul, space agencies need to figure out how to overcome the tedium, personality conflicts, and emotional toll of extended separation from loved ones.
Crews going to Mars will be training together for at least a couple of years. So they're going to work out the kinks, they're going to find out how to work together, because that's the real key in any kind of situation like this.
With Mars simulations like this, we'll definitely be able to solve the technical and psychological challenges of establishing a base on Mars and forge a path to the future of life in space.
In the future, researchers at the International Mars Base make a remarkable discovery. A particular rock specimen completely changes the way humanity thinks of its place in the universe. The sample confirms that ancient fossils similar to those found on Earth also exist on Mars. This rock reveals that the complex forces that cause life to evolve are not uncommon. In principle, life, possibly even complex and intelligent life, may have evolved across the universe.
While the first research station on Mars is likely to be small and scrappy, a long-term base with dozens or even hundreds of people will need more in the way of complex facilities and buildings. However, transporting the materials to build large-scale, heavy-duty habitats from Earth is unfeasible. How can we build a permanent outpost using what's already on the red planet? I'm in Brooklyn, New York to meet a design team with a unique solution.
So this is Mars Ice House.
That's a habitat?
That's a habitat.
Rebecca Pales-Friedman and Michael Morris run the forward-thinking firm Space Exploration Architecture. Also called SEARCH, they won NASA's International Mars Habitat Design Competition.
What we do is we design habitats for humans to be in outer space.
We use indigenous materials, materials that are native to the planet, and we create a beautiful living experience that's also functional for the astronauts.
But that's easier said than done in the red planet's lethal environment.
The primary goal will be to protect against radiation from both solar rays as well as cosmic galactic rays. The best material to protect against radiation is actually water, which makes up most of our atmosphere.
And Mars does have plenty of water ice to work with. On Earth, we're largely protected from harmful cosmic radiation thanks to our thick, oxygen-rich atmosphere and magnetic fields. But with barely any atmosphere, the surface radiation on Mars is hazardous. High-energy particles from the cosmic rays damage human DNA and can increase the risk of diseases like cancer.
So like our atmosphere protecting us here on Earth, we thought, why not build an ice house? We created this double shell structure for additive protection, but also to have a bigger space.
That is so cool.
Part of our objective was like, if we go all the way to Mars, why should we live in a cave or a concrete bunker? People should be able to look outside, look at the strangeness of the landscape, but they should also receive the daylight, which is very similar to our own here on Earth. They have 25-hour days, and they have about 50% of the light that we receive here on Earth.
But a long-term settlement will need dwellings that are more complicated than what can be built with just ice. The search team has a mind-blowing solution for that too, using the mineral-rich Martian soil, or regolith.
This is Mars X House. X House, the objective was to build with Martian regolith, or concrete. We mined the exterior shell from the soil, and we mined the interior pressure bubble out of high-density polyethylene that we drew from the atmosphere. So it was like mining the sky and mining the soil to create one building.
Another crucial innovation is that this habitat is constructed before the astronauts arrive.
It's built by the time they get there, and then when they get there, they can just do the work that they need to do.
And the team has devised one far-out method for building these prefabricated dwellings remotely.
All the buildings that we've been designing are all 3D printed.
Wow, that is so cool.
Search's plan calls for construction robots to be sent to Mars in advance to build the habitats using 3D printing technology.
There are no construction workers on site. We have to anticipate everything that could possibly go wrong and design that beforehand.
But these incredible structures aren't just computer models. The design team is working with state-of-the-art 3D printers to make versions of them in real life. Using a mix of materials similar to Martian soil, the printers build actual freestanding versions of Search's structures. The future of this breakthrough technology is much closer than I could have imagined.
We'll be building a habitat on the surface of Mars by 2028.
Incredible. And so
that, I know that doesn't sound like close, but that sounds pretty close to us.
I mean, and that sounds incredible to me. So no, that's absolutely amazing.
Innovative designs using materials found on Mars will pave the way for the first settlers to arrive to move-in ready homes. But what will happen when the supplies they brought with them run out? They'll need food and oxygen to survive in this alien hostile environment. For humans to create civilizations anywhere in space, we'll need to build self-contained and self-sustaining ecosystems that work like our home planet. But how can we build water cycles and farm in desert wastelands like the Moon or Mars? I'm outside Tucson, Arizona, where researchers have been conducting decades of groundbreaking research to achieve this ambitious feat.
This is a grand experiment in earth sciences, started about 30 years ago, trying to understand how the Earth works. They decided the only way they could truly understand how the Earth controls itself is by creating a facsimile of it. This is called Biosphere 2, as we live in Biosphere 1.
Dr. Joaquin Ruiz is the director of Biosphere 2.
It almost reminds me of like a palace. Not like a laboratory or research environment, but more like a science palace. Can you tell us about what's going on here in high level?
Sure. Right in front of us is the rainforest. You have a big ocean, and then you have a desert.
It was an audacious idea. Build a small-scale version of Earth in completely closed quarters. In a matter of years, they recreated a wide array of ecosystems that originally took billions of years on Earth to evolve. To succeed, Biosphere 2 needed to be completely self-contained and sealed off with nothing brought in or taken out.
We have to recycle the nutrients. We're recycling our water, our air. We're recycling everything.
In 1991, 8 volunteers, or biospherians, lived inside Biosphere 2 for 2 full years. Like a future habitat on Mars, Biosphere 2 had to be perfectly thought out and highly engineered. The health and safety of future explorers depended on its success. Any habitat on Mars will need to remain completely sealed off from the toxic environment that surrounds it. But keeping it sealed and structurally sound is a near impossible task. Sudden changes in internal air pressure could destroy the structure itself. So, the engineers of Biosphere 2 came up with this innovative solution called the lung. And Deputy Director John Adams takes me inside.
We're going into the lung of Biosphere 2, and when it was originally constructed, they designed it to be hermetically sealed, but they knew that they had to deal with changes in pressure. And this is the device that they came up with to compensate for that.
Whoa.
This is just a remarkable structure from an engineering perspective.
I didn't expect to walk in and see this.
The lungs are connected to the rest of the biosphere by a series of tunnels to continuously balance the air pressure inside.
What we're standing inside of is an extremely large diaphragm, and that diaphragm helps to modulate pressure inside the facility. As it has a counterweight, an aluminum dish, flexible rubber membrane. The combined weight of those two is 40,000 pounds. And the only thing that's keeping it up in the air as you see it right now is differential air pressure.
Wow, that is pretty insane.
This weighted rubber diaphragm regulates the 2 basic kinds of air pressure at work. As the temperature outside heats up, the air inside the biosphere warms and expands. Inside the lungs, the increasing air pressure pushes up against the weighted, flexible diaphragm. Without the diaphragm's flexibility, the air pressure would shatter the glass of the sealed habitat. In space, an incident like this would be deadly. As the air in the biosphere 2 cools and contracts at night, the weight of the diaphragm presses down. By reacting to the changing of air pressure, the biosphere 2's lungs continuously adjust, applying the right amount of force to keep the air pressure even throughout the closed system habitat.
This is where air travels back and forth as we modulate the pressure changes within the facility.
On the red planet, temperatures can fluctuate more than 100 degrees Celsius over the course of a single day, which means a feature like these lungs is essential to any future Mars habitats. And to sustain life, these habitats must cycle and recycle the air for humans to breathe, and also grow plants for food. On Earth, this process links animals and plants. Animals breathe in oxygen and breathe out carbon dioxide. Plants absorb that CO2 and discharge oxygen. In the biosphere, this fundamental cycle is recreated with the rainforest. Researcher Laura Meredith is conducting an experiment to test its resilience.
All right, so I'll show you the rainforest. So this is almost 30-year-old tropical rainforest.
This is beautiful.
Yeah, it's nice. Even 3 weeks into drought, it's pretty green. Some of the trees are dropping their leaves, the soils are drying out. But really, I think this rainforest is showing us that it has quite a bit of resilience.
In the rainforest, plants absorb humans' waste carbon dioxide the inhabitants breathe out. This subsequently helps the plants grow, and in the process also creates oxygen for the inhabitants to survive. Growing a stable, resilient plant ecosystem will be essential to the survival of any future inhabitants of the Moon or Mars. However, the first biospherians weren't so lucky. 16 months in, the oxygen levels dropped precipitously. It turns out, there was something the original designers underestimated: microbes. Microbes in the soil and in Biosphere 2's cement absorbed more oxygen and released more CO2 than originally estimated, nearly leading to disaster. Fortunately for the biospherians, they intervened and used additional machinery to pump in oxygen. In space, an oversight like this would be catastrophic, which is why it's important to simulate and fully test a system like this before building a biosphere on another planet.
Because it's a closed system, you really need to understand how your ecosystem works. Biology is really incredible in its resilience, and that's something that you would really want to have as a component of your ecosystem on another planet.
Can we create a closed living system like this one on Mars?
It's an immense challenge to put together all the complex components, but I am sure that we can create one.
Thanks to the original founder's dream, Biosphere 2 is a reality. And while this living laboratory has had many challenges, Biosphere 2 is providing crucial insights into ways humanity can build self-contained ecosystems. It's innovations like this that will forge a path to future long-term settlements on the Moon or Mars.
I think it's really going to take the entirety of society's focus for us to really start expediting the process of getting people to Mars. But I think one of the things that a few scientists brought up that I spoke with was this idea that we should focus on keeping our home here habitable and not trying to run to other places.
Some argue, why spend billions of dollars to get to Mars when we could be using this money and ingenuity to solve existing problems on Earth like poverty, disease, and climate change?
Should we flee this planet? If we can't figure out how to live wisely and live well on this planet, I think we've been given quite a treasure here in this little third rock from the sun.
But Catherine also thinks humans are destined to set foot on the red planet someday.
I think it's certainly technically possible to have a sustainable habitat on Mars, and it's conceivable that it could happen within the next couple of decades.
The technical challenges are pretty immense. It's going to take thousands of people to work on this and concentrate on it at the same time. But we feel that it's important that humans see these planets firsthand and we'll learn more.
Others look at the greater good that can come from new breakthroughs.
It's not going to be cheap, it's going to be difficult, and we're going to need to push towards a common goal to get people to Mars, and hopefully beyond eventually. And every time we are able to accomplish something like this, we can then bring that technology back to Earth. And the more advanced these technologies get, the more advanced the technologies on Earth get. And I think that's hugely beneficial.
And the discovery of life elsewhere in the universe could have a profound impact on humanity.
I think the odds of us being the only life on the universe is very low. I think there's life somewhere, so that's again why it's critical for us to actually continue to explore, to continue to look outward, because I do think eventually we're going to find somebody else.
As a scientist that's long dreamed of exploring space, I'm excited about overcoming the challenges that will lead us to become a truly spacefaring civilization.
Getting humans on Mars and settling in a civilization, I'd love to see that in my lifetime. Will I see it in my lifetime? I'm pretty sure.